Okay, so hello everyone. Today I'm going to explain how you can solve the problem of creating a regular expression that can test a string and check if it's divisible by 3 or divisible by 5 or 4 or any number. And by the way, this can be a binary string for the sake of simplicity, but you could make, in theory, a complicated enough regular expression to check decimal numbers or octal numbers or whatever you wanted. But that would be a very a very dense graph, as you'll see later. So first, let's start with the problem. We want to create a regular expression to check whether a number is divisible by 3, and we can actually reframe this problem and just say n divisible by 3 is the same as n mod 3 is equal to 0. So we want to check that n mod 3 is equal to 0. So when we use a modulus operator on a number, n mod 3, there are 3 different states that the output can be in. 0, remainder 1, and remainder 2. I'm going to draw these in circles and have them as nodes in a graph. If a number is divisible by 3, then we know that the remainder must be 0, so I'm going to draw another circle around here to show that this is the desired state. And when we input a number, we're going to assume that an empty string is equal to 0. So we'll draw a little arrow here to show that this is our starting node. So we're going to start from divisible by 0, and then we're going to check each character in the string and kind of follow a sequence of inputs and then see if the final whole string is divisible by 0. So now that we have these 3 states, we want to think about drawing lines between them. And this is going to be a digraph which has directions. That's in the name. And we're going to want to know how to get from one state to another. And by doing that, we got to look at how binary numbers work. So quick recap. Each place in a binary number is a power of 2 from the right to the left, going upwards, starting from 0. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. And then when we add together all these place values, we will find what the answer is. Oh, sorry, what the decimal representation of the binary number is. Okay, so that doesn't answer the question of how we get one state to another, but it helps us get there. If we have this empty string is equal to 0, that's what we're assuming. If we add 0 onto the empty string, then the string remains divisible by 3. So we're saying, if a number is divisible by 3, and this applies to any number, as I'll prove in a second, and we add a 0 onto a number that's divisible by 3, it remains divisible by 3. So let's have a look at this binary number 0, 0. Well, that's just 0, right? Okay, let's actually do a good one. Let's find a number that's divisible by 3. 3 is divisible by 3. There we go. Okay, what happens to the value of this binary number as we add a 0 on? Well, what happens is, instead of the place values being 1 and 2, they change to 2 and 4, and we add a new one here. We're shifting the places of all these numbers that used to be here over here, and this, which used to be 3, now becomes 6. We're multiplying it by 2 as we shift the bits to the right, left by 1, because all the place values will increase by a power of 2. When we add a 0 onto a binary number, all we're doing is multiplying it by 2. And then we can just start to think of this in terms of decimal numbers. If you have a number that's divisible by 3, 3n, you multiply it by 2, you get 6n. And 6n is also divisible by 3. So we know that if we add a 0 onto a binary number, it's still going to be divisible by 3. if it was already divisible by 3. Okay, so let's just think of that same logic with 0 for 1. If we have something that is remainder 1 from 3, for example 1, 0, 0 is 4. Alright, let's add a 0 on the end and see what happens. Okay, it shifted everything to the left by 1 again, so same thing happens no matter what the binary number is. Let's think about this in terms of decimal numbers. What can we represent a number that's divisible by, that when you divide it by 3 you get a remainder of 1? You can represent that as 3n plus 1. 3 times any constant plus 1. If you divide this by 3, you'll get a remainder of 1. So we have this, and we know that adding a 0 on the end will multiply it by 2. So it becomes 6n plus 2. And this can be rewritten as 3 times the number plus 2, because this plus 2 can't really be put into these brackets. So we're going to have a remainder of 2 after we add a 0 onto the end of a binary number that has a remainder of 1 divided by 3. So we'll draw an arrow from 1 to 2 with a 0 on it. We're saying if we add a 0 onto a number which has a remainder of 1 when divided by 3, we get 1 in state 2. Okay, now let's do it for state 2. Same thing again. 2 times 3n plus 2 is 6n plus 4, which is equal to 3 times, and now we can actually factor, we can rewrite this as 6n plus 3 plus 1, and we can factor this by 3. You get 3 times 2n plus 1 plus 1. So what we have now is 3 times a number with a remainder of 1 on the end. So if we add a 0 onto the end of a binary number that has a remainder of 2, we get one that has a remainder of 1. Let's just test this out real quick with an example. So number that has a remainder of 2, let's just go with 5. Simple. 1, 0, 1. Now let's add a 0 onto the end. What does it become now? Place values and add them up. So we get 10. And 10 divided by 3 has a remainder of 1. So it has worked. Perfect. Okay. So this has worked. Now, what do you think will happen if we added a 1 onto the end of a binary number? Let's go through an example. Let's say we have the number 101. This is 5. Actually, let's just get a number that's divisible by 3 to start off with. 6. So 110. Okay, let's write down the place values. 1, 2, 4. Alright, again, when we add a 1 on the end, it's going to shift all these place values. So it's going to shift the numbers from here onto here. So all the place values of the numbers we had already multiplied by 2. In other words, this previous bit multiplied by 2, we got that already from the 0. But instead, we're also adding 1 on the end. So we can describe adding 1 onto the end of a binary number n as making it become 2 times n, as everything's bit shifted to the left by 1, and then adding 1. So it's very similar to the 0. And now using this, we can kind of fill in the rest of our graph. If you have 2 times a number divisible by 3, and then add 1, we get 6n plus 1, which is basically just that again. Except this is that is wrong, I'll just write it here. 3 times 2n plus 1, divisible by 3, remainder 1. Okay, so we have remainder 1. When we add a 1, we get remainder 1. Perfect. Okay, now if we have a number like this, add a 2, and add a 1, we get 6n plus 3, which can be written as 3 times 2n plus 1, which is remainder 0. So let's add that to the graph as well. Okay, now we have 0 and 1 from the first state, 0 and 1 from the second state, and then we just need 1 from this last state now. Okay, let's do it. So 3n plus 2 times 2, add 1, we get 6n plus 5, which is the same as 6n plus 3 plus 2, which is the same as 3 times 2n plus 1 plus 2, which is something divisible by 3, remainder 2. So when we add a 1 at the end, same thing, remainder 2. Now we have this graph, and so if I was a human, even with an extremely what's happening? Even with an extremely long binary number, let's just 1110010111101. I can now go number by number, go through this graph, and see if this is divisible by 3. Let's just check this out, what the remainder will be. 1, so now we're here, 1, back, 1, there, 0, 0, 1, 0, 1, 1, 1, 0, 1. So we've got that this mod 3 should be equal to 2. And we can test this out on Google now if you want. Let's test this out. So we have 111, we have in binary 11100101101 mod 3. I don't know how Google works with mod, but we'll just do that. Okay. Alright. And we get 0B10, which is our result here. So clearly it's worked. Perfect. We have a DFA that we know that works now. This is what's graphs called DFA. How do we convert this to a regular expression? Okay, so we know that the number's going to start here and it has to end here for it to be true. So, what we want to do, when we reduce a DFA down, we want to try and remove every single node apart from, it's called the root and the sink node. This is going to, since the root and the sink node are the same, root i.e. starting node, sink i.e. ending node, we just want to get rid of every single node except this one. And when we get rid of a node here, we need to update these connections. So I'm gonna walk you through an example just to illustrate what I mean. So let's draw this again, and we're gonna keep the 0 here, and we keep all the previous connections with 1, and we have 2. Except we don't have 2, we're getting rid of it. So let's do a quick recap on regular expression rules. Parentheses, groups, expressions together. Square brackets, sorry, not square brackets. An OR operator, a pipe matches A or B. And we can put that in brackets if you want to group it as one expression. A or B. A star means 0 or more of A. So if I wanted to represent, since 2 is gone, we want to look at what arrows are going into 2 and what arrows are going out of 2. And for every arrow that's going into 2, we look at the node which it came from, 1. And then every arrow going out of 2, we connect the node from which the arrow came from to the node which the arrow is pointing to. In this example, we can just reduce this down to, so to get to 2, we have to do 0. But we're trying to get back. So 0 is 0. But this does not count for the expressions where it can go 0, 1, 1, 1, 1, 1, 0. So what we do is we are at 1 star 0. So this means you do 0, you have 1, 0 or more times, so you don't have to have 1, but you can have it as much as you want, and then 0 again. So we can kind of replace this entire node with just this one regular expression here. And then now we just do the same thing again. So if we just move this up, make space. So now we're on the last bit. I'll just draw it on this side, I guess, over here, since it's just going to be one node. So since we're trying to just get from the node to itself, we're just going to have a bunch of connections to itself. And what I like to do to make it not too complicated, I like to just keep these ones, these kind of things here already. So we have 0, and then again it's kind of the same thing. We have 1 and then 1 again, except we can repeat this whole thing. I'm going to put this in parentheses to group it. We can repeat that whole thing 0 or more times and then return 1 again. So now we have this. And so we can replace this with we can replace these two arrows with kind of one big arrow. We can say so the arrow just deleted was 0. We can just say 0 or that. This is our expression, 0 or 1, 0, and then all of that. That is how you get from a binary number divisible by 3 to another binary number divisible by 3 is by following this. And so back to our regular expression, to test whether a number is divisible by 3, this is not the end, because this can be repeated any number of times, and we've also defined that an empty string is equal to 0. So what this means is that we can just write this as star on the end. If it's not repeated any times, well, 0 is divisible by 3, so it works. And if it's repeated multiple times, no matter how many times you repeat it, it's still going to come back to itself. If you find a string that does not obey this pattern, you know that it has to not be divisible by 3. And so let's test this out. I prepared a little test thing here, so we can test this out. And let's write a regular expression here. So what do we have? We have 0. I'm going to put this in brackets. 0 or 1, 0, 1 star 0 star 1. 1 open bracket 0, 1 star 0 close bracket star 1. Exactly what we've got there. Repeated as many times as we want. And let's check this out. So I'll be surprised if every single one of these numbers is divisible. So clearly something has gone wrong here, and I think it's because what we've said here is that we're matching for this expression repeated any number of times, but what we should be writing is that it has to start, so this is the start of the string, then that has to happen, and then the end of the string. So it's not going to match just any old string. Let's test it again. There we go. 0 false, 1 0, sorry, 0 true, 1 0 false, 1 1 true. That is, I'll be surprised. Let's check this out. So I wonder if these are both divisible by 3. Wow, that's divisible by 3. And just so happens the two number I've chosen are both divisible by 3. And let's test out these random tests. We'll just check these ones. Oh, whoops. Yep, that's got a remainder. And that's got a remainder. Oh, I copied the wrong thing. That's got a remainder as well. So perfect, our program works for divisible by 3. So now let's try and make one that's divisible by 5. Okay, and we know we have to have these start end brackets and then some kind of expression that's repeated many times. This is kind of the framework we have for a regular expression. So we're going to be using this one. So we'll have the div5 regex this time. So let's go through this very quickly. You can pause the video if you want at any time, but let's do it. So we have our states are 0, 1, and I'm actually going to draw this as a square because it's probably going to be easier, or like not a square but like this. 0, 1, 2, 3, 4. Circle, circle, arrow, circle, 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 circle. Okay, and we should be able to figure this out pretty quickly. 0, 1, 0, 1, 0, 1. And then from 4 to this is 0, 1. And then this is 0, and it's very ugly, but we'll just do that, 1. And that's done. Okay, we have this ugly graph, but you know, it's fine. Maybe you could find a way to rearrange these nodes so that it looks nicer. But anyway, I think I'm going to try and get rid of this 3 first, because it's got this ugly connection here. Okay, let's try and get rid of the 3 first. So just separate that off. Okay, so 3. We want to look at all the nodes that are pointing into it. So we have 1 and 4 both pointing into it. So we want to update the connections on 1 and 4. So let's redraw this diagram, hopefully a bit neater. And then we have a 1 and a 2. And then we're getting rid of the 3 right now, so we have a 4 here. Okay, so we got a... Let's just draw in all the connections we have right now. 1, 1, 0, 0, 1, and that's pretty much it if we ignore the 3 here. Okay, nice, that looks a lot neater already. So we want to look at all the nodes that are going into 3. So we have 1 and 4. So let's highlight them. I don't know where the highlight button is. Probably... this looks like a highlighter. Hopefully. I don't know what this is. I'm not going to bother with that, man. We'll just circle them. So we have 1 and 4. These are the ones we have to update. Bang, 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 and bang. Okay, let's not label all of them. So the ones that are going into it are these 2. And the ones that are going out of it are these 2. So, let's look at 1. 1 goes into 3. So we're going to want a connection that goes from 1 to itself, now that we're getting rid of 3. It's going to be 1. Since this has no repeated node, we can just kind of add together these connections. So from 1 to itself, it's 1, 0, because we just go 1 and then 0 again. Pretty simple. Alright, from 4, sorry, we haven't finished with 1 yet. We also want a connection that goes from 1 to 2. So we're going to have 1. So from 1 to 2, since we have 1 already here, what we can do is just move this along and kind of just like add an OR here. 0 OR. Alright, now let's think. We want a 1 and then a 1. So 0 OR 1, 1 to get from 1 to 2. Okay, perfect. Now let's try from 1. We finished 1. Let's go on to 4. So we need a connection from 4 to 1. So connection from 4 to 1. We have this 0, 0, 0. So we have 0, 0 is from 4 to 1. And then from 4 to 2, we have 0, 1. Perfect. Now we've done that. Okay, now let's try and get rid of 4, just to make it kind of more flat. You can see now how writing an expression for something divisible by a higher number, or imagine instead of zeros and ones, you had 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and you're trying to make like divisible by 23 or something. Like, oh my god. You would have so many nodes, so many connections, you would have to get a computer to do that for you, and there is algorithms that can do that. So yeah. Okay, let's draw the connections we have right now. 1, 0, or 1, 1. And then we have 1 going here. Okay, perfect. Okay, so let's see, what nodes do we have that are going into our 4 that we're getting rid of? We only have 2 actually, which is pretty nice. This arrow, my bad, that arrow, my bad, that arrow, good enough. Okay, and we have these 3 connections so that we need to think about. Okay. let's think about this. So all we want to do is update the connections on 2 right now. Oh, I forgot to add this loop here, my bad. Almost forgot. Okay, there we go. So we have that. So we want, again, something that goes from here, from 2 to 1. We want to get one that goes from 2 to 1. So 0, and then 0, 0. But you also got to remember that we have this loop here, which means that in between the 0 and the 0, 0, we could have a 1 that's repeating 0 or more times. So we'll add 0, 1 star, 0, 0. Perfect. And now we just want a loop on the 2. So 0 and then 0, 1. And then again, we have the 1 star, 1, 0 more times in the middle. Okay, we have this and this now. Perfect. Now let's move on to the second to last step. 0. And we're going to try and get rid of the 2 this time. Okay, let's add the connections we already have. So we have a 1. We have a loop here, and a 1 there, and a 1 there, and that's it. Okay, now we're gonna want to add a few more connections. So what nodes are going into 2? Only 1 is going into 2, right there. And what are the connections from 2? These ones. So we need to draw a new connection from 1 to 1, which means we're going to have an OR here. And we want to also draw a connection from 1 to 0. So let's draw the connection from 1 to 0 first. So we have 0 or 1, 1. And since we got an OR there, we will kind of want to group this together. 0 or 1, 1. And then we want a 1 going back. But we also have this repeated expression here. So we need to write this. 0, 1 star, 0, 1. And this whole thing can be repeated 0 more times as well. And then we gotta have a 1 back. Perfect. So that's that connection. And now we have to do this loop here. So we have 1, 0, OR. And then we have 0 or 1, 1, followed by this again. 0, 1 star, 0, 1 star. This repeated 1 or more times, and then back again. So then we'll put this in brackets. 0. Well, we don't have to put it in brackets, but I think it makes more sense if we do here. Or it's just easier to look at. So 0, 1 star, 0, 0. Okay, perfect. So we have, to get from here to here, we have 0 or 1, 1. Then we have this repeated any amount of times, and then back again. Or we could just have this 1, 0 loop here. So this is the expression we have for a loop here. Okay. Perfect. Okay, now let's kind of shrink this up. Now that we have this, let's expand this a bit. That is ugly now, but whatever. So we're just trying to make this one single node now. We have the circle, circle, arrow, and we want to find the loop. So we have one loop that says 0, and then we're going to have OR, and then the rest of it now. Now this is where it gets confusing. Okay, 1. Then I'm just going to relabel this as A, for simplicity's sake. A star, we have 1, A star, and then I'll just label this B. 1 A star B. Starred. This can repeat 0 more times. Okay, now we've got this. So let's just write down here. What is our final expression going to be? It's going to be 0 or 1, and then we have to put A here, starred. 1 0 or 0 or 1 1. 0 1 star 0 1 star 0 1 star 0 0. Bang. So This is very confusing. So we have all of that, and it's A starred, and then we have B, which is going to be 0 or 1 1, 0 1 star 0 1 star 1. I'll put that in brackets just for simplicity. So we have 0 or 1 A, which is that. Whoa. It says 10 or, and then all of that stuff. Starred, A star, and then we have B, which is that. Perfect. Okay. 0 or 1 A star B. Now we can finish that and put a star on the end. That is our regular expression. Okay, let's test this out. Back to VS Code. That is very complicated. So we have this now. Oh wait, sorry, I just replaced the older regex, didn't I? Alright, let's add it here. Div 5 regex. See how complicated that already is. Let's test it out. 0, true. 2, false. 3, false. 5, true. True, false. And we can kind of see because it ends in 0 or 5, we know. True, false, 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 false. There we go. Let's test it with some more random numbers. Yep. And it works. Okay. If you have any questions, I'll be willing to answer it in the comments. But that's basically the gist of it. I hope that helps you understand how to do it. And yeah. It's my first video kind of explaining stuff, so hopefully it's all right. But yeah, thank you for listening. Hope it helped you. But yeah, see you guys.